session then, and welcome all to the ISPSG webinar series, the first one that we have this year. ISPSG then, who are we? First of all, I can tell you who I am. I'm Pierre Alman and from Sweden, and when I look out through my window now, it's snowy with white covered branches on the trees, etc. It's not the same situation for our presenter, and perhaps where you are. But I'm been president for 1.5 years, and I'm representing IFPAG, the International Function Point User Group, where I have been members since the 90s. And why do we have, let's wait, so why do we have an organization like ISPC? It's because you come to a point where you need to have some help when you want to improve the planning and management of your software projects or the applications, how you take care of them. And for example, when you estimate your projects, how sure are you that you're making good estimates? To do things like that, you need some kind of data. You need to check that against other kind of similar projects or applications. And that's what we have. We have a big repository of data. We are the only one that is not dependent. We have over 9,000 projects and more than 1,100 application data for those. And we're also creating analysis reports that you can have a look at. And one very good thing that you should keep in mind, and I really want you to use this kind of opportunity. If you submit data, we have very easy spreadsheets to fill in with the data that you have for your project. Then you will get a free comparison against similar projects without any cost. It's totally free. So please do that and try that. Then you will really see what we can do and for you. ISPAC is a non-profit organization, and it's built up by their members, and some of them are the gold members that are contributing most to this organization. We have from Mexico, as you can see, we have from China, Finland, we have from USA, as our presenter represents, and Italy, IFPAG from USA that I'm representing, from Japan, we have from Spain and from Netherlands. So we're covering most of the world with different kind of organizations and companies that are joining us. And the board there who runs this, or the executive committee, it's me, that I'm the president. We have a vice president and treasurer, Helen from China, and the immediate past president was Harold from NESMA in Netherlands. And then we have an administrative part, the executive director, that is Paula, and she is in Australia, and that's why she can't join today, because it's a bit too early for her. It's 3-4 o'clock in the morning, something like that. So when we have this presentation now, please put your questions in the chat. And you can also use the chat to inform us if you, are there anything special you want in the upcoming webinars, please let us know. And also I will open up so everyone can use their microphones to have their questions done that way after the presentation. So it's a very honored to introduce the speaker of today. It's Dan Galorath, from the CEO of the Galorath Incorporated in USA, and he's sitting there in California and enjoying the nice weather, I can see. And Dan, he has been involved within engineering and estimating analysis for 40 years, so he is very, very experienced. So he will discuss today about the uses of size for new and updated programs, and the uses of size for evaluating open source and other kinds of software. So I will stop sharing here and I will hand over to my friend Dan. Please go ahead, Dan.
Okay, good morning, everybody. It's 9 in the morning here, and yes, you're right. That is a picture of my backyard, and it is cold here today. It's under 70 degrees, so we're kind of complaining. But as was said, we're going to talk about sizing, going back in history, the present and future, and also how to use lines of code, which I know a lot of people demonize now, as a size, in addition to functional methods. Already covered. I know you all know this, but why is size so important? When you have a painting contractor come in and ask for a customer quote, what does he do? The first thing he does, he says, well, how big is the house? How many square feet or square meters is the house? And of course, they look around and they look at the neighborhood and they look at the quality of paint and things, come up with other parameters. But the biggest thing is the size. Same with software. Knowing the size, whether it's functional, whether it's any other method, or the anticipated size, is a huge help in figuring out cost, schedule, benchmarking, and all kinds of things. There's lots of viable sizing approaches. If I'm missing any, forgive me. I didn't mean to drop any. There's the 3 wonderful methods that are ISO standards for functional size. My company, Galorath, who does the SEER models, is size agnostic. We use all these sizes when appropriate, and we support everyone who's doing some kind of a careful sizing. Physical size, source lines of code. I know some people say source lines of code don't work at all now. They work in many cases. We're going to spend some time on that. Simple function points, the one I'm most excited about right now, a way to get size with just a couple of inputs. Object points, use case points, requirements, and many others. We've experimented with all kinds of things. We've even experimented with things such as the amount of compression in a requirements document. Could we use that as a size? The more compressed, when you compress it, then the less uniqueness. And as we've been looking at size for decades. Again, I started in this business. I started as a software project manager. I got interested in estimating and sizing because we were always too optimistic in how long things were going to take and how much they cost. And so I've been doing this ever since. Again, there's lots of reasons to use sizing and the IceBags database. I've been supporting IceBags now for, gosh, probably 10 years, maybe more, because I saw it was an opportunity to help. We've got databases that we collect and they're proprietary, and other people got databases, and we work with the U.S. government's databases and others. But I thought it was really a good thing to have a universal database that everybody could participate in and everybody could share. So that's why we're involved with ISBSG. It can be used for simulation and forecasting and benchmarking, setting goals for programs, estimation, and a number of other things. IceBags has been doing this now, I think you might have said, for many years. Some of the projects are very new, some of the projects are older. But I suggest to you, even some of the older projects, the sizes for a particular applications may still be relevant and probably still are relevant. Now, again, a lot of times people say, oh, Slack is terrible. Don't use Slack ever. You know, Slack isn't always the villain, and functional size isn't always the hero. We have used Slack over the years and been very successful. And in fact, the largest US government database for sizing is Slack, source lines of code. We're going to look at source lines. It can be useful. Not in every case, but in many cases. It can be verified. We can run code counters to find out how many Slack. Now there's special care that needs to be done, and I will talk about that in reuse and generated code and other things like that. You can't just say, okay, here's my gross Slack and go off of it. And again, there's simple standards and tools to count it for existing systems. It's hard for a developer to estimate how many new Slacks something might be, but if they know other systems, is it bigger or smaller, that can work pretty well. And again, there's a fair bit of bias in parts of the industry, at least today, that functional size is the only way to do things. Functional size is wonderful, and Slack can be very helpful as well, as we'll see. Here's an example of bias. The big advantage of function points, validity and independence versus Slack both compounds estimating under uncertainty. So what they're saying is that that the growth is in Slack is something you can't predict. Well, the growth in function points and the growth in Slack both are usually based on the growth in functionality. So sometimes there's a bias, and this is one of those bias things. Functional size, wonderful. Don't need to worry about languages, don't need to worry so much about reuse and generated codes, etc. There are several ISO standards. I've heard some people say, oh, there's no standard for Slack. Well, that's not true. There's a standard, it's just never bothered to put it as an ISO standard. University of Southern California published it. Galorath supports it. QSM supports it. Price supports it. I think everybody supports that standard. It just wasn't made an ISO standard. It's pretty simple. Anyway, if I look back in history, have I seen people misestimate things with Slack? Oh, yeah. Have I seen people misestimate things with functional size? I sure have. I've seen several things. One is I've seen people who didn't understand how to count or estimate functional size, and that's been an interesting problem. On the other hand, I've seen people who invented their own sizing methods. It's the company X functions without telling anybody. And I remember one time we saw a system where there was a 70% differential on the same system with two of the world's best function point counters. And it was because different levels of information was shown, different things were questions were asked. I'm not suggesting functional size doesn't work. I'm suggesting that every size method needs care. Oops. Now, again, I've been doing this for a long time. When I first started, people were using a lot of source lines of code some. But if you go back in history, people used memory words, and I've done that myself. If you have a 64K of memory system, we can figure out about how many lines of code that can hold. Now that went into assembly language lines of code, which went into assembly derived from source code. If you we'll look at some of the original C code, and you could actually see the assembly code that would be developed from it. And from assembly derived from source, that is, if I had a Fortran statement, how many assembly language lines, I went to just using the Slack, the source lines of code. From there, effective size, not just the gross number of lines. For example, if I had a system that had a million lines, we changed 10, the fact that we had changed it and what that does to the overall size, the amount of work we've got to do is important. We said to see things like the Galorath COTS cognition. How much work does it take to use, learn, and apply commercial off-the-shelf software? And of course, all the wonderful functional sizing methods, relative sizing, is it a little bigger, a lot bigger than something else? And effective functional size, applying both functional sizing and the ways to compute effective size. And I'm going to go through these. But so started out with how many memory words. In fact, that's still used sometimes. Occasionally, if there's some of the Internet of Things processors, you've got a ROM and it's 8K of bytes or whatever it is. You can figure out a size based on 8K of bytes even today. Here's how we did it in the good old days. And again, we did this a lot at one time when we've been doing this since for a long time. If you had 64K bytes of ROM or PROM or whatever it was, and you had to have a 20% reserve for growth so that you didn't run out of memory completely, that says you had 52K bytes of code. Well, depending on the machine instruction, in this example, there's about 6 bytes per instruction. If you look at a PDP-11, as I recall, the average number of bytes per instruction was 4, but depending on the line, so this is about 8,700 lines of code. Is that a terrible size? I don't think so. I think that is substantiable. It's provable. We can count the number of lines of code when it's all done, etc. Now, the interesting thing in the old days like this, 20% was almost always the reserve. Leave 20% room for size growth. Well, we all know size often grows more than that, and that became a problem anyway. But trying to get 10 pounds of peanut in a 5-pound jar, once you exceed the reserve, that can become very difficult. But this was a viable sizing method, and some of the major US defense systems today were sized by this. Now here's an example. PDP-11. I'm an old software guy. I love the PDP-11 instruction set. I love the auto increment, auto decrement in assembly language. Well, with the original C code, you could actually look into it, and you could see SEE from the source code what machine language would be generated. So here we can see these lines of C code would generate in PDP-11 assembly language these lines. So for a while, people used these generated lines. But then we realized we could use the source lines. Of course, today, source lines in assembly language probably don't usually have much of a relationship. But this worked, and again, is still viable in some cases. Size by comparison. I love size by comparison. If you knew that you had a system and you knew it was 750 function points, and you could compare it to another system, and using relative approaches. Now, this one is the Galorath Seer approach, but there's Tom Soddy's got a program called Expert Choice, and there's several other ways to do this. By comparing bigger, smaller, a lot bigger, a lot smaller, we can generate the size for a new item fairly accurately without counting anything. So we know, in fact, here's a great example for ISBSG. You choose the 3, 4, 5 systems that might be analogous to what you're building. You put them into, again, the Galorath or another relative sizing approach, run through that, and you end up with a new size range based on the bigger, smaller analyses from the users. I've had great fun with this and great success with this over many years. I remember at one time, we were doing a lot of work for the US government. And in the US government, the program office, the one that's the sponsor of the new development, they want it to look as cheap as possible. In fact, sometimes they don't care if it overruns later, as long as they get their program approved initially. So they would always try to fool the size and comparisons. It's even got consistency checks, and so ours does, and so does Tom Soddy's, and would still catch them and generate reasonable size ranges. It's quite amazing. I think there might be some spreadsheets in the industry as well that do small pieces of this that are free. But again, this comes with Seer, and it's Tom Soddy's Expert Choice. I love it. Now, here's one thing we learned over the years. In needing to substantiate size, and we've gone through this with extreme rigor with government organizations and others. They didn't just want to say, here are 100 function points. In this example here is lines of code. They wanted proof. So what we did is expert judgment would be one. You ask somebody how many lines would it be. And in this example, the person said, oh, least case 12,000, likely 15,500, most 17,000. That's somebody's guess. Then we go in by analogy from, again, the government's got databases, and there's some Slack in ice bags as well. And from there, we found out 19.8 to 20 at minimum, 24/7 likely, and 32.5 most. Using another sizing database, we found a range of 8,000 to 46. In any case, we went through all the different ways we could by estimate comparison. Then, in our rules, we dropped the lowest of the low because things usually don't get smaller. We usually use the likely, and then we use the range, the most. So we have a range of size with both the size and the uncertainty. This works for functional sizes. This works for lines of code. This works for use case points, it works for anything. The beauty is, when you're all done, you can show a table like this. Again, this could have been function points, and people can see the range, understand the range. It's more substantiated than just a single person counting. So we do this a lot for customers. Many times. Now, converting lines or functions or object points or anything else from the gross, again, what if we had a, what do they say, 750 function point system, and we're adding 3? Well, 753 function points is an interesting number. It doesn't really help us much to figure out how much work's going to be involved. We found using effective size, we published this, we donated it to IFPUG. So IFPUG published this some years ago. We've put it in the public domain using new pre-existing and how much redesign, reimplementation, retest, so that you can come up with the effective size, the effective number of functions, effective number of lines or whatever. And so that gives us the effective amount of work. Rather than saying it's 753 function points, it might be that it's we're only adding 3, but we've got to go back and rework 100, and we've got to reverse engineer a couple of hundred. Gives us an opportunity to see how much work this is going to be versus how much stuff will, when it's all done, how much work it will be. It can be very handy. Here again, we've donated this. It's published in one of the older IFPUG books. It's all over the place. And you're welcome to use these factors if you want. This shows breaking down redesign, reimplementation, or retest, how much of it's architectural, detailed, etc., and then generating an effective size. Here we can see from our Seer product, total size of this one was 201 functions, and that was about 137 effective size. So even though we were building a 201 function points, we had the work of building 137. Helps you compare 2 different alternatives, help you to see how much work is done. And again, I've heard so many people say, oh, there's no standard for counting lines of code. Here's the standard for counting lines of code. Non-comment line terminating semicolons. Most modern languages we can count, so we can build a database of actuals using that method. Again, there's a code counter from the University of Southern California. We've got one, they're all over the place for free. And in this example here, we see some code. And the blank line, obviously you don't count a blank line. The comment line is a comment, not a line of code. We don't count that. Here's a line. This construction standard is equal 321 semicolon is a line. Another line, won't go through all this, but when we're all done, there are 15 carriage returns here. This is what people have traditionally thought of as a line of code, sort of, but there's only 7 logical lines of code. So there is a standard. It's used by everybody that uses lines of code, I think. And it works. Now, some people will say, well, what if program A is a better program than B? Yeah, there's a little slop in there. There's not 10% slop. One time somebody came to me and they had a line of C code, and in it they had done about, I forget anymore, 20 some lines of code, all in one big silly C statement. They said, look at this. This line of code didn't work. Well, I said, well, yeah, you never get this through quality review. It was unintelligible. And so lines of code can be helpful in many cases. Does that mean I prefer lines to functions? No, I prefer what we can get our hands on. And functional sizes remove a lot of other hassles. But this can be very helpful. Here we can see using off-the-shelf software. We may have some developmental software. Suppose this is our 750 function points. And we got some glue, some code that is making the commercial off-the-shelf software work along with the developmental software. And this little piece in the circle here, or this little darker green thing, that's how much the piece in the circle is how much we actually have to build. The piece in the other color is about how much we have to comprehend. There's work and time in comprehending. And then there's some customization. This would be some new functional size. Anyway, if we break things down this way, we can get the size of anything relatively quickly. We've built too something we call COTS cognition, commercial off-the-shelf cognition. And again, this worked. There are 3 different ways to do it. How many features? Basically, it's the application type and how much you think you're going to use, and how many objects. And we've used this for a long time. And I was fascinated when one of our customers called me up and they said, "Dan, we use I don't remember which of these 3 methods. It must have been the features, and we counted the number of items in the table of contents for the documentation. We use that as the input, and we came out within 2% of the actuals." I was like, "Wow, that's really interesting." So the ability to comprehend and size can be lots of things in addition to the functional things I had in the front or lines of code. Now, another use for size, for functionals, somebody asked a question. I was trying to get it and I failed. I'll come back to it, I guess. If you know the number of lines of code in an open source system, and you can then run the static analysis, you can know not just the lines, but you can know the errors. You can know lots of things about that software. So suppose you decided to use a piece of software, and it was in PHP, and but it was commercial off the shelf. If you go into these databases, and there's 2 of them, I think. This one database here by the name changed recently. It was called Coventry. They were acquired. I'm not sure what the name is called right now. You can get the number of source lines of things like Linux or the PHP compiler or other things. You can also get the number of defects found, if best they can tell, and you can use that to figure out and estimate how much work it's going to be to use that. Now, you probably wouldn't have to do it for Linux, but what if we're using a graphics package, a commercial off-the-shelf graphics package? So again, this is a way to look at commercial off-the-shelf software, or open source software, find out what the size is, what the defects are, what the risks are from a database that's open and available. We already talked about comparison sizing, so I'm going to skip that chart. So let's see, we have one chat here, if I can get it. Oh, no question. So my goal here was to go through and look at sizing, a little bit of the history of sizing, and to spend a little time on lines of code. There'll be ISPSG will have other webinars that will cover all the different varieties of functional sizes. But the bottom line here is that you don't need to demonize lines of code. If you're careful, they can work. There's many viable ways to count size. Standards are key, whether it's ISO standard or whether it's the USC standard for counting lines of code. Functional size is helpful. Functional size is not a panacea. People sometimes mess up the functional size. Whatever size method you're doing, we recommend using a sanity check. Here's another opportunity for ISPSG. Suppose you had people count a functional size of a program and they came up with 1,300 function points. You could go into ISPSG, define analogous systems. If it showed analogous systems were generally 2,000 to 3,000 function points, you may have a big red flag saying, hey, we've not captured the eventual functionality of this system. Having data is valuable. And again, don't dismiss lines of code counted with appropriate standards. Now that's the conclusion of my talk. Do you want to open it up for questions? There weren't any on the chat.
Let's see if we have any. No questions so far in the chat. So please, let's see if I can.
Well, if people have questions later, by the way, that last bullet, keep seeking better and better approaches. We should never be happy. You know, look at what the various standards are doing. They're always trying to get better. If anybody has questions for me, you can email them, or you can phone me, or whatever you'd like to do. We haven't been in the office for 9 months now, but that's insane. But they will forward to my home. Well, thank you everyone for coming today.
Okay. Yes, you can wait. I can share my
Somebody actually
screen.
supposed to be seeing a presentation. If y'all didn't see this presentation, I don't think.
Yeah, it was at the end. So yeah, I can. Let's.
Are we making these slides available?
Hopefully they will be available. Yes.
Will they be on the Ice Bags website?
Yes, we are
Okay.
trying, and we will hopefully get the recording also shared later on, but it's not decided yet how to do it.
All right. Well, thank you, everybody. Stay healthy.
Yeah, I can say, yeah. If you're interested in more webinars, you can look at our website, www.isbsd.org. And the next one that is coming is February 24th, and it's 1:00 p.m. Central European time. And it's about benchmarking agile teams. And then it's Harold van Heringen, that is our previous president, and he's representing the Netherlands Software Measurement Association, NESMA. And also, if you belong to a gold member, please check your ISBSD benefits with them, because there are very, very good benefits that you have if you are a member of a gold member. You can do some use a tool to investigate data in our repository, and you can get discount by if you buy products from ISBSD. So please do that. Remember that. So no questions. Let's see in the chat if there is anything coming up. No, it doesn't seem to be that. So great, thank you, Dan, for your presentation. It's very interesting to hear your experience about measuring things within IT and the use of that. And most of all, thank you all participants that have joined this presentation. I could see that you're coming from different parts in the world, not only from the Americas, so from other parts in Europe as well. So thanks a lot.
Hey, bye-bye.
And yeah, I hope to see you within about 1 month.